Good afternoon.
Good.
All right. Good evening. Man. Word. All right. Okay. Like I said, we are sort of burning through like the next few chapters because I'm picking out certain things and things that we could skip and save for later. So that we kind of end in a nice spot at the semester. So today we're talking about functions, which we have here, f of x. That's how you say that. F of x is function notation. And basically it says we have this function in terms of x. And we can use lots of different letters. We use function notation in higher math all the time because typically we're not dealing with just one equation. We have multiple equations, and so we use function notation to distinguish between different functions. So I might name a function g of x equals 1/2 x minus 2, and h of x equals negative 3x plus 7. And again, it's just notation so that you can be like, let's look at the g function, and you know which one I'm talking about. We're talking about the one with the g. All right, or let's look at the h function. We'd be looking at this function here, okay? The of x really just means in terms of x. And in terms of x means you're going to have some terms. We have two terms here. And guess what? They have an x in them, all right? So we can have function notation using all kinds of different variables. I could have h of v, which would mean this is the h function in terms of the letter v. So there'd be v's in this equation, 4v minus 8, maybe, okay? We can use any letters we want, okay? So it's just notation, and we really like function notation because of reasons like this. So this says f of 4, and what does that mean for you to do?
Substitute x.
Yeah, substitute the 4 in place of the x. You can see how it just sort of lines itself up, and it's literally saying replace the x with a 4. And so we do that, and we go to our function here and replace the x with a 4, which would give us 11. And so we would say f of 4 equals 11. And we don't have to divide by the 4 because it's just notation. And we want to leave it like this because this is actually very informative. And so when we look at this notation, it's telling us we had an input of 4. And after plugging it into some function, then the output was 11. And so what we have is an input-output ordered pair or a literal ordered pair on the graph, okay? And that's something important to remember, all right? That's actually an ordered pair on the graph of this function, okay? And so because it's a function, what that means is there is, for every input, there is exactly one output. For each input, there is exactly one output. You can't plug in a number and get 2 answers out, all right? And when that happens, it's not a function. It's craziness, is what it is, which we're also going to graph as well. AJ?
I don't know if this is able to do that with radical standard.
And so the question is a square root function a radical? It is actually. So if I had the function, like let's say f of x equals the square root of x minus 3, you'll notice there is no plus or minus here because this is the principal square root. So they want me to literally, I'm just graphing the positive radical function, okay? That's a really good question and a really thoughtful question, actually. Because this, but I won't go there. We'll graph those later. Okay. All right. Yeah. So anyway, we'll leave it at that. Good question. All right. So again, one. Determine if the set represents a function. Determine if the set, and I left that, your book uses a couple different words, but the set given or the graph, I don't know. Yeah. So the collection of all of our ordered pairs creates a graph. So when we find all these input-output ordered pairs and put them all together, that's how we create a graph of a function, or a graph in general. And so here we've got this crazy shape here. And we want to know, does that graph represent a function? What do you think?
No.
No, why not? Vertical line test. I was wondering if you guys would remember that. Yeah, there's a vertical line test. So first of all, we have our Cartesian coordinate plane here, our x and y axis, and if you're thinking in terms of ordered pairs, well, no, like any of these ordered. Oh, well, here we go. Okay, when x is 2, what's the output? There's 2 of them. That's exactly right. There's one up here. Let's see, that's 2.5. So there's this ordered pair 2, 2.5. But there's also this one down here, which is the ordered pair 2, negative 2.5.
More like 2.25.
No, because this is counting. This is 1, 2, 3. Oh, pay attention to tick marks. Yeah, they're confusing, right? Okay. So is this a function? No. Okay, so because we've got one input has 2 different outputs, that does not meet our definition of a function. The shortcut answer is, when you have a graph, does it pass the vertical line test? Which means if you draw a vertical line, does it intersect one time only? In this case, it intersects twice. It's not a function, okay? Not a function, fails vertical line test. I abbreviate vertical line test, VLT, all the time. Vertical line test.
Plus.
Okay, so now looking at letter B. Is the set of all of those ordered pairs a function?
Well, there's the same line.
Yeah,
It's a
it is.
straight line. It's a
So
line.
can't cross twice.
Is it a vertical line or a horizontal line?
Oh, it's a horizontal.
Oh, okay. So, ladies and gentlemen, you guys are very analytical, so usually this isn't a problem for you, but I'm always going to say, when in doubt, graph it out. Yeah. Graph it out. So the rule is each input has exactly one output. And so if we were to actually make a quick little sketch here, -2, 1, -1, 1, 0, 1, 1, 1. Does it pass the vertical line test?
Yes.
Yeah. Yeah. So this is a function. It passes the vertical line test. If I was to draw a vertical line, it only hits 1 point. There are no points that are stacked on top of one another. Okay. All right. Yeah, each input has exactly one output. What if I were to say, give me one ordered pair that makes it not a function? What would that ordered pair be? -2.
Anything
Other than 1. Yeah, -2, 5 would make this fail, because -2, 5 would be up here, and now those 2 points are stacked and it fails our vertical line test. Okay. Because an input can only have one output. That input now, -2, is going to both 1 and 5. That's like trying to be in 2 places at once, which is a little bit ridiculous.
What if the y-intercept was changed for the x? Like the 1 was.
Yeah, so that'd be another point. So if it was 1, 0, 1, 0, that'd be right here. And again, those points are stacked now, makes it not a function.
No, I mean like if you change it and make it instead of a horizontal line, make it vertical.
So if you have a vertical line, is it a function?
Never.
No.
Okay.
Yeah, technically undefined. Undefined. Yeah. All right, example 2. Evaluate each function for the given values. Evaluate each function for the given values. This is leading up to what we do in calculus. It's called the difference quotient, which we will do soonish. Actually, in a couple of days.
Oh, are you serious?
No, just the difference quotient. Yeah. Which is all the algebra that you need to know to take a derivative. So you actually are learning the algebra necessary to do the derivative, which is the calculus. You just don't know what it means yet.
It's like crappy geometry.
I love geometry.
I hated geometry.
It's because you just didn't have me as your teacher.
No, you would have hated me as a student in geometry. You think I'm bad now? I'm so bad for you.
Yeah. At the beginning of the year, I figured he annoyed Georgini so much.
All right. So we have our function. This is our f function, which is x squared plus 2x minus 3. What shape is that? Parabola. Good. Okay. Just checking. I'm going to ask you that all the time. Knowing the shapes of things is huge. That is like what I believe algebra 2 in college and pre-cal is. All right. You want to know what things look like. What is f of -2 telling you to do?
Input -2 for every x.
Yes, input -2. So we're going to plug in a -2 for all of these x's. And I'm just going to move along. I don't like to do this, but I'm going to move to the right instead of down. I was like, I don't want to use another sheet of paper. Okay. What is -2 quantity squared? +4. Thank you. And then here we have 2 times -2, which is -4. And then -3, which gives me -3. -2, -3 would be the ordered pair, yes. Yeah.
Wait, do we have to wait?
No, no. In fact, I'd normally go down the page. My final line would be f of -2 equals -3. That's good notation there. All right. So if f of -2 means input -2, what does f of a minus 1 mean? Input a minus 1. Yeah, no. For some reason, in other classes, you guys are extra special, but in other classes, it seems different to them. And maybe you probably can recognize why that seems different, but the idea is the same. In place of x, we're now plugging in a minus 1. And it is literally in place of. There are no more x's anymore, okay? Plus 2 input, a minus 1, and then -3. So what do you have to do?
Can you just like
You just put that in for X, right?
distribute?
What was the question? I'm not listening.
What do we do next to simplify?
You do
Yeah.
A minus 1 times A minus 1.
A minus 1 times A minus 1, right? You gotta write that out 2 times, maybe. What do you get when you FOIL that together? A squared
Minus 2A.
plus 1. Very good. Again, you might need to write it out 2 times if you don't have that pattern memorized, but you do need to FOIL it out. And then we need to do what with this 2? Distribute. Okay, so positive 2A minus 2, and then the minus 3 there.
And then you simplify it.
Yes, and just combine like terms. So I have A squared
4 minus 4. It's minus 4. Because you subtract 2 and then
Yes, it's minus 4. Sorry. I was a little overwhelmed there. Okay.
Like simplify it, you can get like A plus 2A minus 2.
No, you don't have to factor. The question was, do you need to double bubble this? Not necessary. So literally, we are just simplifying. There's no solving going on. You are just doing exponents and multiply and combine like terms. So,
just leave it like
yep, that's it. Done.
that.
All right. And so what does f of a plus h tell you to do?
Put in A plus H.
Input A plus H for
Input a plus h in place of the x here. So we have a plus h quantity squared plus 2 times a plus h minus the 3. All right, so again, same idea here. Why is this more complicated?
there's A and
An A and an H. Yeah, there's 2 things. This is the precursor calculus right here. So again, you could write A plus H out 2 times and then distribute. A times A would give you A squared. The outside would be AH, and the inside would also be AH. So it would be 2 AHs. And last times last, H to the second, H squared. You can distribute plus 2A plus 2H. And then the minus 3. Yeah, oh, yep, that's it. There are no like terms in this particular case. So yeah, this is it. F of A plus H equals, seems long, doesn't it? I don't know, it feels incomplete, doesn't it, when you can't like put it back together? Like, wait, I want to make it prettier. Is it okay?
Just keep it small. Don't distribute anything. That's the answer.
All right, do you guys have any questions for me?
Oh, this is it.
All right, that's it, yeah.
I'm gonna go.
The first few are very simple, not a lot of work to show, but once you get to like, I don't know, 22. I